Hello, students, and welcome to our continuing series on the principle of mathematical induction. And so far, we've been proving using mathematical induction to prove things that have some sort of formula. And now we want to use it to prove something a little bit different. And it says here we want to prove that for all n greater than or equal to 1, this expression, 4 to the n minus 1, is divisible by 3. And so before we dive into this, and let's just try a few things, right? Let's just try and just see if this is true. So let's try a small number. Try n equals 2. Well, does this work? Well, 4 squared minus 1 is equal to 16 minus 1, which is 15. This is divisible by 3, so this works. Let's try something bigger. Let's try maybe, n equals 5. Okay? So 4 to the 5th power minus 1. Now 4 to the 5th, incidentally, is 1024 minus 1, which is 1023. And this is divisible by 3. And just in case you don't believe me, if we do 1023 divided by 3, you get 341. There is no remainder. Okay, so this works. All right, so this is what this statement is saying, that no matter what number you put in here for n, whether it's a small number like 2 or 5 or something gigantic like 4 to the 10th power or 4 to the millionth power, this entire expression will still be divisible by 3. Okay? And so let's get to the business of proving this, and this is a little bit trickier than what we normally do. So we always start with the base case, or the base step. And this is when n equals 1. So let's see if this works. 4 to the first power minus 1, is this divisible by 3? And notice here we don't have a left-hand side and we don't have a right-hand side, because we're not trying to prove that a formula is true. We're trying to prove that this particular property, divisibility by 3, is true. Well, 4 to the first is 4. Minus 1 is 3. So yes, okay, 3 is divisible by 3. Okay. So at least we know that the very starting point is true. Now let's look at the inductive step. And this is going to be a little bit tricky. So we are going to say that assume true for n equals k. In other words, 4 to the k minus 1, we can assume this. Okay. So in other words, if assume that 4 to the k minus 1 is divisible by 3, now we need to show that 4 show true for n equals k plus 1, namely 4 to the k plus 1 minus 1 is also divisible by 3. All right, so now this is a little bit of a tricky thing to do. Okay. So now this part is going to get quite weird. Okay, so and this is where the power of induction really comes in. So we are going to rewrite this statement as this whole thing here is equal to 4 to the k plus 1. But instead of writing this minus 1, we're going to say minus 4 plus 3. Okay? So what we're doing here is rewrite negative 1 as negative 4 plus 3. Okay, so this expression here becomes negative 4 plus 3. Now there's nothing wrong with doing that. And if you're wondering why do we do that, let me just show you as we complete the proof, and then we'll come back and reflect on it a little bit. So now what we're going to do here is we'll group these two things together, and we're going to factor out 4. So we end up with 4. And instead of having, we have to divide this expression here by 4. So what we end up here is 4 to the kth power minus 1 plus 3. Okay, so hopefully this didn't freak you out too much. All we're doing here is dividing this term by 4, so we lose one of the powers, and then we divide this one by 4, so this becomes negative 1. Now if you take this and distribute it, you can see that we'll get back to this line. So now the rest of this is kind of weird. We're just going to express this using only words, okay? So we know that this thing here is divisible by 3 from the inductive hypothesis. And this is a good thing to know, that if you don't have to use the inductive hypothesis, you're either doing something wrong or you don't need to use induction at all. Okay? And then this is a multiple. This part right here, let me use different colors here. This whole thing right here is a multiple of a number that is divisible by 3. So we can say that this is divisible by 3 because it is a multiple of a number divisible by 3. And then so now we have 4 times this whole expression here. This is divisible by 3 for this reason. And then we add 3 onto it. So when you add 3 on, you're just going to end up with another multiple of 3. So, whoops. In our last statement, we can say that adding 3 to a multiple of 3 will create another multiple of 3. Okay. Therefore, this entire expression is divisible by 3. And remember that this entire expression that I just circled is actually equal to what we're trying to do in our inductive step. Okay, so this completes the proof. Now again, this stuff is weird, especially when we're dealing with things that don't have formulas in them, but just look over this and convince yourself of what I just stated here about multiples and how that works. Okay? And keep working on this. This is going to test your patience as much as it tests your mathematical understanding. Thank you for watching, and have a wonderful day.